Okay, right, nothing happened, great. Okay, first of all, did anybody have any problems doing some Ka or Kb calculations for those that had a go? So did anybody continue with, if you're busy with the CH3062, or did you try any problems? Yes, two of you are typing that I know you've finished or you're getting ahead. Okay, it went fine, great. Okay, but I know that some of you haven't because you haven't got to the booklets yet, so I thought what we could do is a few examples. So if you can get out your calculator and just have it available. I think further up somebody did give a link to a calculator if yours is still in rehab. I know one of you was still in rehab, but have one ready. So let's start with this one. These are a mixture of different things. So it's calculate the pH of the following solutions. I've got 5 in total. So the first thing you need to look at is it a strong acid, strong base, weak acid, weak base? So I've got here HNO3, nitric acid. What type of substance is nitric acid? Strong acid, strong base, weak acid, weak base. Okay, Layla, it is an acid, correct, but it is a strong acid. So Leah, well done. As a tip, if you're not sure, you'll notice, so you'll be able to get this right. Okay, great, Layla. If you see something like a Ka given, as in that one down there, you'll know it is weak. It might not be a weak acid, okay, because you can be given a Ka for a weak base. In fact, you never get given a Kb, you always get given a Ka. So if you see a Ka, it means it's weak, either weak acid or weak base. If you're not given a Ka in a problem like this, it means it'll have to be a strong acid. Now, there were a few acids you had to know for the exam. They would expect you to know them as either strong or weak. I went over that last time. If we've got time at the end, I will be looking at it again, actually, in our next section. So you need to remember that HNO3 is a strong acid. So if it's a strong acid, remember our EQ method. Our EQ method is basically saying equation first, then expression, and you don't have an expression for a strong acid, and then the calculation. So by equation, I mean the chemical reaction. What can I write for this one? So thinking of it's a strong acid, by definition, what does a strong acid do? Completely dissociates. So the reaction I want, or the equation for the reaction I want, is HNO3 going all the way to H, well, let me say H3O plus. We're assuming this is in water. Okay, just to show the balancing in a way it's not quite balanced the best way, and then it's NO3 minus. So what have I got in solution when I have a nitric acid solution? What species? Okay, I think I'm back. And it seems as though it was just me that went out. Right, great, Laura. Just checking, can you all see the screen? Yep, okay, great. So we've got only these two items. As was said, we've got the hydronium ion and the nitric acid, the nitrate ion. What we also have got in water is H2O molecules and a bit of hydronium and a bit of hydroxide ion from the water dissociation. But we're going to ignore that as being too small to influence my hydronium ion from here. So now we've done the equation part. There is no expression. Why not? Why don't we write an expression? So a few of you are typing. Well, in a way, there's always an equilibrium if it is an equilibrium, of course, but it's so far to the right, then it's we assume that it's all products and few reactants. Right, David, this pH, sorry, I've just given the answer there, because sometimes this is what I send out to students for extra practice. So if we don't get that answer, then we know we've gone wrong. Okay, so you wouldn't be given the pH in the exam. Okay, so going back to this, it's to go to the original question. With the expression, there's no expression because it's not a weak acid or base. We only use that expression for a Ka expression or Kb expression when it's weak. Okay, so the next thing is we just write in our formula, and this is just simply pH is equal to the negative log of the hydronium ion concentration. Okay, and to substitute into that, so that's really a level 2 thing, and of course you've got to know that same equation for level 3. To substitute into there, we, as I say, have made the assumption that all our hydronium ion comes from the acid. So we can say assume, we can ignore the water, so we can assume that the H3O plus is equal to what? If all the hydronium ion comes from the nitric acid, what is my concentration of hydronium ion? Right, the 0.0350. How many significant figures are in that number? 3 significant figures, the 3, the 5, and the O. Okay, and, oops, mole per liter. Right, so we just simply substitute that in. So we say the negative log of 0.0350, and I hope you all get an answer of pH 1.6. So if you can try it out, that would be great, because if you get a different answer, then we can check to see why. So some of you are typing. You can say, well, if you finish the calculation, yep, great, you got a 4. You can just say agree with the value 1.46 or disagree if you didn't get it. Great, right. Okay, Laura, sometimes if your cursor is in that little typing box, then it comes up as typing. So you've got to try and just press on another part of the screen, and hopefully you get there. You know, it takes it out. Okay, right. It could be your clones, yes. Okay, so that's a straightforward question. It's pretty much a level 2 question. Okay, let's do this one. Now, I hope you remember from your 3061 or from our solubility that our calcium hydroxide is actually not very soluble at all. But what does dissolve of the calcium hydroxide, does it stay as calcium hydroxide, as in like a molecule of it, or does it stay as calcium ions in solution and hydroxide ions in solution? A tiny bit that does dissolve. So a few of you are typing the calcium ions and hydroxide ions. Great. So it is a strong base. So it's not very soluble, but it is a strong base. So it's exactly the same as what we've done at the top. So I'll just use a different color again. We always start with the expression, with the equation. So I hope you're going to get the same. You're welcome to type the answer as well of what the equation is. It's going to be calcium ions and hydroxide ions. Now the whole point of the equation is not just to work out what to substitute into the Ka and so on expression, but it's also to get the ratios, because if you don't see the stoichiometric ratio, you're going to make a mistake. Okay, so that is really important. So if I've got 1.3 times 1.35 to blah 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 calcium hydroxide solution, how many hydroxide ions have I got? Not just 2 hydroxide ions. So if I've got a 1.35 blah blah blah, you double that. Okay, twice as many. Okay, so where we had here assume the hydronium ion is the same as the nitric acid, what we have to do now for the calcium hydroxide, we have to assume, because we're going to say, well, let's ignore any contribution from water because it's so tiny. Okay, we're going to assume the hydroxide is equal to 2 times, and it's twice because of my stoichiometry, 2 times 1.35 times 10 to the minus 3. Okay, and we can simply then now write the formula. First of all, why did I go hydroxide, and why didn't I just try and work out hydronium ions? So I'm trying to work out pH, so why didn't I work out hydronium ions? So some of you are typing. Okay, and yep, because it's a base, we don't know the hydronium ions straight off. We can work it out using KW, but it's just much easier working with hydroxide and at the end converting. So what I'm going to use is POH. So because we're working with hydroxide, I'm going to first work out the POH and then work out the pH. There are different ways, so if you want to learn a different way to do it, I can show you different ways. But so my equation I'm going to use here is now POH is equal to the negative log of the OH minus. And we can use the same expression because remember our KW was equal to our Ka times Kb, and it's the OH minus times the, in fact let's actually remove that Ka because that sounds confusing, seeing we're working with a strong base, but our Kw, remember, is equal to our H plus times our OH minus. As I say, it's derived in your booklet, I'm not going to do it here, but just to try and sort of show you why we can suddenly change from a pH over there, we can now use POH with exactly the same formula because they are related. Okay, a number of you are typing, but let's just carry on. So we've got the POH, so now we just substitute that number. So can you try and work it out? Twice 1.35 and get the negative log of that. I'm going to work it out myself. Okay, 2.57, great. Okay, so your POH is equal to then 2.57. By the way, I just want to make sure that when you write your calculations, make sure they make sense. I find a lot of students just tend to write equals, 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 and they're actually changing the function. So for instance, if I wanted to now work out the pH from the POH, it's simply pH plus POH equals 14. So I could now say to work out the pH, it's equal to 14 subtract 2.57, okay, is equal to, and you should get 11.1 about, if that's correct over there. Now, I've deliberately done this to simply equals, equals, equals. You get 11.4. Okay, as I didn't check these figures, So if other people get 11.4, that could be also when that's very good, Laura. Okay, so that's where I made a mistake when I made this up in the first place. So okay, it should be 11.4. I'll make sure I correct it if I send it out anyway, because you are supposed to double the OH. Okay, because you have 2 OH minus for every 1 calcium hydroxide. Okay, now can you tell me what is wrong with my working here that I've done? I've said POH is equal to negative log of OH minus is equal to 2.57. Because I want to work out the pH, it's equal to 14 subtract 2.57, which gives me an answer of 11.4. Yeah, I've rounded up to 5.7 to a 6. So what? Right, Laura, it makes it look as though the pOH is equal to 11.4. So please, it is actually a very common error. Make sure whenever you're writing it down, it's clear what you're calculating. Right, David, I didn't write the pH plus pOH is equal to 14. That's not totally necessary to have written it down. I mean, they wouldn't mark you down if you didn't do it. But it was just simply the way I just simply wrote equals, equals, equals. It looked as though my final answer was the pOH is equal to 11.4 and not the pH. So just check up that you write in what you are calculating. So in your head, you know exactly what you're doing, but what's written on paper looks like mathematical nonsense. Okay, so those are pretty straightforward. Okay, let us now go on to this final one, and I didn't leave myself much space. I'm going to delete all that. Okay, because I might need some of that space up there to continue on with. This is now, as I say, this is a clue straight away. If you get given a Ka or a Kb, then you know straight away that you're dealing with something that's weak and you need the expression. Okay, so how, of course, do we start any of these calculations? What do we need to do? The equation. So the equation is going to be our formic acid, or methanoic acid if you want the IUPAC name. Formic acid is just because it comes from ants. So it's H plus HCOO minus. Oops, that's a bit long for a charge. I am actually sloppy in terms of I didn't write the H2O, so one should actually do that. So it should be CH3O plus. That's better. David, I'm not. Formic acid actually does have a bit of a smell, but that's what, when they bite you, that's what they inject into you, and that's why it stings, because it's acidic. Okay, but I haven't smelled formic acid, I must admit. Let's carry on with this. What you've then got to do is, after equation is expression, and we have a Ka value, I mean a Ka expression, because we are given a Ka, but more importantly, in our equation is H3O plus. What expression would I have to write if I had OH minus in my equation? The Kb. Okay, so just make sure that that's very clear. So what we have is the Ka. So even if you're given the Ka, always double check, have you got the H3O plus as a product? Now it should always be a 1-to-1 ratio, because that is what's given in the standard. They don't ask you more than that. Now if it's a weak acid, we can assume that not very much dissociates. So if I write my assumptions down, what can I assume about the concentration of my formic acid? So a few of you are typing. Right. Okay, so David, you've gone ahead. Laura, you're correct. You can assume that your formic acid is the same as this because very little of it dissociates. So, you know, it's like saying what's 1 subtract 0.000000001 or whatever. It's going to be pretty much 1. Okay, so you can assume that your formic acid is equal to 0.120, okay, mole per liter. Now, David, you actually had the H3O plus there of 10 to the minus 7. You can't assume that the hydronium ion is that. That's only if it's in a totally neutral solution and you've got an acidic solution here. So you can then make an assumption about the hydronium ion, and what would that be? Okay, we've made an assumption about the formic acid. Now we've got to say something about the, and I'll just change my color because it's getting rather messy. What assumption can I make about those two? Right. Okay, David, the H plus is the same as the formate, not the OH. Okay, but I think you meant the H plus thing. They're equal concentration. So we can also say, you can assume, sorry, I shouldn't have that there. So we can assume that H3O plus is equal to the formate HCOO minus. Sorry, this is not a very dark color. I'll change color very quickly now. So if I've got that, now we substitute. Okay, so we've done the equation, we've done the expression, and now that we've done the assumptions, we simply substitute. So I'm going to just get rid of that and carry on at the top here. So let's carry on. We now say our Ka, which we are given the value of, is equal to H3O plus squared all over 0.120, and we are given the Ka, so it's 1.8 times 10 to the minus 4. Okay. So in order to solve for this, the easiest is to first take across that, so keep that as squared and take across that 0.120. So you still got 1.8 times 10 to the minus. I hope you can jolly well follow what I've written here because my handwriting is terrible and I have to multiply it. Are you all clear that you have to multiply it, or are you not sure? Okay, and as I say, anybody that's not sure, please feel free to say you don't know, because there may be somebody else that's too shy to say something. So it's just the straightforward maths. If you want to cancel something at the bottom here, you have to multiply both sides by the same number. So that, I mean, not the Ka, but whatever you've added to cancel that, so that must be also multiplied at the top. And I must probably made it sound more difficult than what it is. Okay, so that is, I'm just quickly cleaning up this mess. Okay, so now after we've worked that out, now take the square root. Correct, David. I've found students tend to make mistakes if you take the square root too quickly, because you tend to say, perhaps take the square root of the Ka without having it divided at first. So just make sure you do that stepwise. Do you get an answer of a pH equal to, oh, I've gone all the way to for the final pH, because once you've worked out the pH, the hydronium ion, you then take the negative log of that. So let me just quickly work out if you've got 1.8 exponential times. Do you get 2.1? Oh, hang on, I haven't taken the square root yet. Before you take the 2 of the square root, you should have something like 2.16 times 10 to the minus 5, I think. And then if you take the square root, I get an answer of 0.00465. Right. And as I say, with calculators nowadays, they're already so fancy that you feel you want to do everything in your calculator and only give the final answer at the end. That's a big no-no. Make sure you show all your steps. You can perhaps miss out 1 or 2, but not 2 in a row. And then when you've got your, and I always suggest putting in units so you know what you're doing and what you're talking about. And my working here shows another error. My blue line says hydronium ions squared is equal to 1.8 blah blah blah, and then I've given an answer of 0.0465. Is that green writing the hydronium ion squared or the hydronium ion concentration? The hydronium ion. So as I say, it's a very common error, and what I tend to do, I'll circle your work and I say stop writing mathematical nonsense. It's so easy to do with these fancy calculators, just you're following the answer on your calculator, that you forget about the writing down, but you've got to show everything. And then when you take the negative log, you should get an answer of 2.33. Quite a few of you are typing. So while you are typing, I'm going to flip to the next question, and I can always go back if there was a query. Okay. Right. Good question, Laura. Shouldn't it be 2 significant figures as the Ka goes to 2 significant figures? pH values in the exam, they're a lot less fussy over, and they tend to say 2 decimal places because I find chemistry teachers tend to see, for instance, this pH as 3 numbers, 2, 3, and 3, but it's actually only 2 significant figures. The 3 and the 3 are significant, but not the 2. The 2 is actually just a placeholder, just like 10 to the minus 4 is a placeholder. It just tells you how many zeros are ahead of the 1.8, which we know are not significant. In a log scale, that 2 serves the same function. However, because there's a heck of a lot of disagreement between teachers about this, because maths teaches differently and so on, they tend to say just do to 2 decimal places. So if you've got a high base, you can go 11.33, that's still acceptable, but if you said 11.333, that wouldn't be acceptable. Okay, so I say pH calculations go to 2 decimal places, because you can't counter that as 2 significant figures. Does that make sense? Now, for those doing scholarship, they like it the correct way. In other words, for scholarship, this, if this is a log thing, this is seen as 3 significant figures. Although I have been told that they're not getting very fussy at all on formulae and significant figures in scholarship, but they're still very strict in the level 3. Okay, so let's go on to the next one, which is what type of substance do I have? So I've got now methylamine. So is that a strong acid, a strong base, a weak acid, a weak base? I'm going to actually make this a bit bigger. Sorry, you must probably be straining to see this. It's a weak base. Sorry, if you find it a little bit small, just tell me to make it bigger. Okay, it's a weak base. So notice though we are given a Ka value. So don't fall into the trap now saying, oh, Ka value, so I'm going to go Ka is equal to so and so. First, write out the equation so you know which one you're dealing with. So if I've got water reacting with this, and excuse my handwriting, so I'm going to form now, because it's a weak base, the hydroxide ion, because bases are proton acceptors, so it's swiped one of those hydrogens from the water molecule, and you're left with the methyl ammonium ion. So it's NH3 plus. Remember, nitrogen can only have a maximum of 4 bonds, and in that case it carries a positive charge. So a lot of people see it as ammonia, and then they'll say CH3NH4 plus, but that is incorrect, because remember it's also bonded to the methyl group. So it says 3 hydrogens and a methyl group, so it's got a positive charge in it. Okay, so now we do the same thing. We write down the expression. Now the expression is Ka or Kb? So some of you are typing. Okay, some of you say Kb and some of you say Ka. It is going to be a Kb because we have the OH in our equation. Remember, Ka has to have the hydronium ion. So our Kb is going to be our OH minus plus our base ion. So that's our methyl ammonium ion all over my weak base. NH2. Now, before I carry on, there are different ways of doing this calculation. So in a way, Layla could be correct, because you could work this from a Ka expression. It's just one I haven't taught in the booklet. If you go through past papers, they tend to show you the 2 different ways in the assessment schedule. It's just a different approach. So if you want to look at that way, and if you like it, so you can find it from an assessment schedule, you can use that way. I just like teaching this one method, and then at least you follow just simply the same method instead of having 2 totally different methods. Right, once I've done the Kb, what do I do next? So I've done the equation, I've done the expression. Now I have to assume correct. I do the assumptions so that I can substitute and do the calculation. So what can I assume will be the concentration of my base? So my methyl ammonia, or methyl amine I should say, 0.1 mole per liter, and I can assume that because I can say it's actually a very weak base, so very little will dissociate, so most of it will just simply stay in solution. Okay, so I've got that. So I'm not going to write the assumptions here, my hand's getting a bit sore with using my mouse. What can I assume about the hydroxide and the methyl ammonium ion concentrations? Okay, again, David, I can't assume that it's my hydroxide is 1 times 10 to the minus 7. I can only do that for a neutral solution. So only if the pH is 7. Okay, no, David, sorry, you can't. Only for a neutral solution of a pH of 7 can you say that the hydronium ion is 10 to the minus 7 or the hydroxide is 10 to the minus 7. For any other solution, the hydronium and the hydroxide will multiply together to form 10 to the minus 14, but they could be in any combination. Obviously, if it's a basic solution, you're going to have more base and less acid, and if it's an acidic solution, more acid and less base. So only if they tell you the pH is 7 or it's a neutral solution. So what we do is we say Kb is equal to then our OH minus squared, because we've assumed that those two are the same concentration, all over our 0.100. It's good to get into the habit of using the correct number of significant figures. Now, can I say that is equal to 2.0 times 10 to the minus 11? No, because I was given a Ka and not a Kb. So what I've got to do is do a little bit of working on the side and work out that Kb. So I can either do it on the side or on the below or whatever. How does my Kb and my Ka relate to each other? I did it at the end of last lesson, but it was quite crammed, I know. But perhaps some of you remember. The clue is Kw, which is 10 to the minus 14. Okay, so Kw is equal to Ka times Kb. So if I wanted the Kb, then the Kb is going to be 10 to the minus 14 divided by the Ka. Do you all agree with that step? Yep. Okay. So I would have to say, and I just do it in my calculator, of 1 exponential 14 divided by 2 exponential 11. And do you get 5 times 10 to the minus 4? And I'm going to keep that figure there. Okay, good. So I can write here 5 times 10 to the minus 4. And as I said, I should have put a 0 in there. 5.0 times 10 to the minus 4. You could have done all this bit of writing all in here as well, because you could have said this is equal to Kw over Ka, you know, and just fit it all in one line. Okay. Now we just simply calculate then for the OH minus concentration. So remember what I said, always take the square root last. Don't be tempted to do it all in one step, but then of course remember not to just put equal signs regardless. So what you would do is you go 5 times 10 to the minus 4 divided by 0.1, so multiplied by 0.1, so which makes it 5 times 10 to the minus 5. Okay, and then you would take the square root. And I get 7.07 times 10 to the minus 3. So I'm just going to continue down here because I'm running out of space. So OH minus, now I'm taking the square root of the above number, and I get 7.07 times 10 to the minus 3. Right, and somebody else does it. If anybody else doesn't get that number, please say so, because it's good to pick up careless errors that can come in. For instance, like we picked up my 11.1 that I got earlier was because I didn't double the hydroxide. So if you get to a different one, we can just highlight how easily something can go wrong if you don't double check everything. Okay, once you've got that, you simply will work out the POH. So to work the POH, I just simply take the negative log of that. And I got 2.15. I hope you get that as well. So to get the pH, it's going to be equal to 14, subtract the 2.15, and sorry, 11.8. Yep. Okay. So do you think that this sort of one is the trickiest, because you've got that extra step of calculating the Kb and then going from POH to H. So this is the hardest type of thing they can give you. Okay. Well, actually I'm going to go to the next one, which is going to be perhaps the hardest because you might not recognize it straight away. So I'm going to just tidy this up. Is there any questions before I move on to point number 5? No. Okay. Right, so point number 5, I've just done it here because I wasn't sure if we'd have the time. This is only tricky if you don't recognize that solution. What can you tell me? What type of solution is that? It is a salt, but what sort of salt? So what I mean by that, remember, an acid plus a base makes a salt. Okay, so David is correct. So better make it clearer what question I mean. Remember, acid plus base makes a salt, but did the salt come from a strong acid, strong base, a strong acid, weak base, a strong base, weak acid? It comes from a weak acid, strong base, which means, remember the first step, so this is step 1 over here. It's just we've got 2 equations to write out. So our first one is my salt being soluble, and if you know your solubility rules, you should know that all ethanoate ions are, or ethanoate salts are soluble. So that will completely dissolve into ethanoate ions and sodium ions. And my ethanoate being from a weak acid will undergo hydrolysis. So this is when it reacts with water to form ethanoic acid again and hydroxide. Now, you should recognize that because that's listed in the exam criteria as one of the weak bases you have to know. So you know that this is going to be a base, and by writing out the next equation you can see that it's a base because we've got the hydroxide being formed. So it's exactly the same sort of thing. Once you've written out the equation, this second one is what you base your expression on. And the first one, why don't we base it on the first one? So some of you are typing. Okay, I'm just going to find it actually is quite common. Never ever put a spectator ion into an expression. If you have a spectator ion in an expression like nitrate or sodium or chloride or something like that, you've done something wrong, because a Ka or a Kb expression has got nothing to do with those spectator ions. They're sitting there doing nothing. Right. Oh, I've suddenly forgotten I've got another meeting to go to after this, so I can't be late. Okay, so right. And what Layla said there is, and Laura, because the OH and H3O plus are not formed, correct? That's another clue. Remember, Ka or Kb has to have either the hydronium ion for Ka or the hydroxide for Kb. If you don't have it, you don't have the Ka or the Kb. So that's a good clue to go for. And Layla, you said the Ka is for the acid. That is one way of going it, but I'd say rather go by, is there hydronium ion formed or hydroxide? If there isn't, you can't write a Ka or Kb expression. Okay, so we use the second equation because we've got a hydroxide there, so it's Kb, and we put in the normal sort of thing. We make our normal assumptions. Okay, there is our concentration of our salt. So can you see how I can make that assumption? My sodium ethanoate has completely dissolved. So if I had a 3.66 blah 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 solution of that, what is my concentration of my ethanoate ions? Remembering it's very soluble, it's completely dissolved. Okay, it's going to be exactly the same, correct. Okay, because all my sodium ethanoate has all broken up into ethanoate and into sodium ions. Okay, and then it's the same thing what we did. We are given a Ka, so we have to work out the Kb from the Ka, and so it's done the same sort of step. There we've worked it out. That should have been times 10 to the minus 4 in there. And we should get an answer of that. Sorry, that's the whole thing, sorry. Let me get rid of that. There's your Kb value. Oh no, that's my OH squared value, and then I can just take the square root and get the OH. From the OH, I get the POH, and then from that, I get my final equation, my final pH. Any questions on working with Ka or Kb calculations? So I lied a bit. Number 4 isn't the hardest one you can get. This one is the hardest, and it's not really the hardest. I mean, it's not any worse. It's just simply that does throw students off when they see a salt and they don't see a base or an acid. And it just simply means you have to just have an extra step of dissolving the salt. Right, so can I move on into species and solution? Right, so what I'm going to do now, I'll make this a little bit bigger. This sort of thing is just what we did, exactly what we did for the calculations. Remember how I started? I said, what sort of substance have you got? Have you got an acid? Have you got a base? Is it strong? Is it weak? For the species and solution, you do exactly the same thing. You have to know, is it an acid? Is it a base? Is it strong acid, strong base, or weak acid? And then if it's a salt, what type of salt it is. So going over here, first work out, is it acid, base, or salt? Does it ionize in water? So in other words, what we're asking here, is it strong or is it weak? Okay, strong or weak. And then that's important for the ratio. Does it form 2 hydroxide ions, 2 hydronium ions? What's the ratio? And then, does any part of it react with water? By that I mean, if it comes from a weak substance, it will undergo hydrolysis. So for instance, ammonia is a weak base, so it'll react with water partially to form hydronium ions and ammonium ions. Or we saw in that last example, our ethanoate ions comes from the weak acid vinegar, or ethanoic acid, so it will react with water to form a little bit of ethanoic acid and hydronium ions. So you must think of those things. And then the final thing which students do forget, so just be careful of that, okay, is this dissociation of water. So when people ask what is present in solution, there will always be a little bit of hydronium ions or a little bit of hydroxide ions. So even if I had a strong acid, say nitric acid, which was the first example we had, if I write my nitric acid, okay, we said it dissociated completely. So we said it all forms hydronium ions and nitrate ions. But do I have anything else in my solution? Bearing in mind this is in water. Right, I'm going to have water molecules, correct David, and I'm going to have a tiny, teensy, weensy little bit of hydroxide ion, because it's not very much. It's something that's probably going to be like 10 to the minus 14 or 10 to something over there. So it's going to be tiny, 0.000000, count the number of zeros, 1 moles per liter. But we still say it is present. Okay, so always then say we have hydroxide present. Okay, so let's go through the examples. So I'll start with an easy. Okay, this is starting with the salt, which is about the hardest one, so I'm going to go further down. You've got a page similar to this in your book. Okay, I've just twisted it slightly on its side. So when you ask what is it an acid or a base or a salt? So that's the first thing. If is it an acid or base, is it strong acid, weak acid, strong base, weak base? Or if it's a salt, is it a strong acid, strong base salt? So by that I mean, if you see sodium chloride, for instance, I hope you recognize sodium hydroxide for the sodium salt and hydrochloric acid for the chloride. So sodium hydroxide, is that a strong base or a weak base? Strong base, correct. And the chloride comes from the acid, so just put a H in it. So the easiest way is to work out what the acid or base was. Add an OH to the cation. So if you had a sodium cation, add an OH, you got sodium hydroxide. For the anion, just add an H to it, so you got HCl. Is that a strong acid or a weak acid? Strong acid, correct. So this comes from sodium hydroxide and HCl, and what will happen is that all of those ions will not react further in water. So my sodium ions won't react with water, chloride ions won't react with water. My hydroxide and hydronium is, because it's a salt, it should be neutral because it's a it's been neutralized. So I have got a pH of 7 for a strong acid, strong base. And the next thing to work out, so what can you tell me, by the way, if I've got a pH of 7, what can you tell me about my hydronium ions and my hydroxide ions? Right, clone 3. Can you see the screen? Yes, good. Okay, so it's actually not getting too bad. So my last question was, if I have a pH of 7, what can you tell me about... Oh, okay, some of you already answered that. They said they were equal. Yep, I've got equal numbers of hydronium and hydroxide ions, and there they are. Okay, it's equal. But if I think of relative concentration, think of you've taken your table salt that you sprinkle over your food and you put it into water. What are you going to have more of? Your sodium and chloride ions or your hydronium and hydroxide ions? So some of you are typing, and I'll just tidy this up. Okay, the sodium ions and chloride ions will be in greater concentration. Okay, might be perhaps a thing in the signal to call the meeting to a close because I've got to dash off for my other meeting. Laura, I'll just answer your question. Doesn't it depend on the amount of water and salt present? Correct, but bear in mind at a pH of 7, it means the... sorry, I haven't got my webcam going. At the pH of 7, it's 10 to the minus 7 of hydronium ions and 10 to the minus 7 of hydroxide ions. So it's going to be such a weak sodium chloride solution, you'll barely be able to taste it, because it'll have to be 0.00000001 moles per liter. So you could pretty much say that the hydronium and hydroxide are in the least amount. Okay, I think I'm going to stop there because I've got to go to the next meeting. Are you all okay with this? This is a really important part. You are definitely going to get a question on speed.
Okay, I think I'm just going to say bye-bye. It's obviously not a good day. It's fifth time I've been kicked out. Right, bye.